Alright, here we are in section 5.4 now. Specifically, we're just going to be looking at equations of straight lines. Up to this point, we've been looking at different ways that you can create straight lines. You can use a whole bunch of points to bring them together. You can find straight lines using the slope with the y-intercept. And now today what we're going to do is introduce a new way of finding lines, and that's using pretty much any point. So this actually makes it a little bit nicer when working through some of these problems. You don't actually have to specifically require using the main thing that we've been looking at, which is y is equal to mx plus b. There's actually another form that you can use. And so I'm going to bring up the PDF real quick. And what we have here are the equations of straight lines that specifically we'll be looking at. Okay, so this is what we've been looking at so far up to this point. Y is equal to mx plus b. And so that one is specifically called the slope-intercept form. The slope-intercept form. The reason why we get that name is it has a slope, and then it also has the y-intercept, which this is the y value of the y-intercept, which is the b. So it's slope-intercept form. The other form that we'll use is called the point-slope form. And so it looks kind of similar to this. It's got the slope, and it has an x variable and a y variable. This here is actually a coordinate. So remember when we were looking and finding the value of our slopes, one of the things that we were using was our y2 minus y1 over x2 minus x1, right? So we took those values, the change in y over the change in x, and we substituted them in to find a specific value for the slope. Now, the cool thing about this is that we can do the exact same thing. We can do that to find the slope, but then we can use one of those points as our x value and our y value and just fill them into this equation to get our equation for the line. So it's actually pretty nice. So what I want to do is there's a couple of different sections in the book. They walk through a few different ways of doing it. I actually want to show you a different way. We'll go through some examples here in just a few minutes, but before we do that, I do want to just point a few things out. One of the examples in the book that you come across are equations of a line that has a slope and they give you the y-intercept. And really all you have to do is take your specific values and just substitute them in. So y is equal to mx plus b. We take the m, which is our variable, or the letter that we use for our slope, and we substitute it in. So first we substitute minus 3/2 in for m to get that. Our b value is actually going to be 4. So that ultimately means that our equation is going to be y equals minus 3/2 times x plus 4. And that's our final answer right there. So again, you can kind of see how this all plays together to give us the slope-intercept form given the slope and the y-intercept. We can substitute those values in and get exactly what we need. So what I want to do is I want to go through a few different examples in the textbook just so how this all works out so you can see it pretty clearly. Let's go to our whiteboard here, and you'll notice I got rid of the glare, and part of the reason why is I just shut the light off and turned up some of the settings on my camera, and so it actually works a little bit nicer. I'm kind of in the dark right now, so I'm hoping this pays off and it won't be too much of a problem for you guys. So you may see me going through this a little bit quicker than I have before. I just want to point that out. So in this question number 12, they're asking us to find the equation of a line that contains the point 0, minus 1, and has slope negative 2. They say to use the slope-intercept form. We can do that. Here's the thing, okay? The book specifically tells you to use certain things in certain ways. When you're doing the questions online, it's not necessarily required to do it the exact way that they're asking you to do it. So what I'm going to do is I want to use the point slope form as often as I possibly can, and the reason why is because it is something that's so new that I want to try to use it as often as I can. So even if the book is telling me to use slope intercept form, I'm actually going to use point slope form to solve these. And you'll see that in the end, when you work it all out, it actually works out a lot more easily than if you were to use what they're asking. Hopefully that will all make sense in just a few minutes. Okay, so let's go through question number 12. Question number 12 says to use a slope intercept form, and let's find the point. The point given is going to be 0, minus 1, and the slope, so we can just say m is going to equal minus 2. They say the slope is minus 2. So now in this case, notice that this actually is a y-intercept. Okay, the point. So this is an x value. You can think of this as like an x1. Here's your y1. Your x value is actually 0, which means that this lies right on the y-axis. If you were to graph it, you would see that is the case. So it's 1 unit below where the x-axis is on the y-axis. So the y-intercept is actually going to be the value b equals -1. Now this works out in this case. Not in all cases. You may have a different point, and I'll go through examples of what that looks like. But anytime you see something that is 0 some number, you know you have a y-intercept. Okay, the line, or the point I should say, sits right on the y-axis. So here's what we have. Let's go ahead and toss in the equation y is equal to mx plus b. And now what I do is I'll just substitute my values in. So I've got m is equal to minus 2 times x plus b. B is a minus 1. So there we have it. So now up to this point we've been looking for the slope and maybe the y-intercept given the equation. So what they've been doing is giving us this first, and then we have to find that. But now in these problems it's actually the reverse process. So we're given a point, maybe the y-intercept, we're given a slope, and we have to substitute those values in. Okay? So this is the answer to this problem. Let me go ahead and do another one. Question 14. They give us the point is 2 minus 3, and the slope is going to be m equal to 3. Okay, so notice this is not the y-intercept. Intercept. Okay, that is important for us to remember. That is not the y-intercept, so we cannot just simply go and use y is equal to mx plus b in this equation. There is a way to do it, but it's way more complicated, and so I'm going to show you how to use the point slope form. The point slope form, if you go back to the notes, is going to be right here. Y minus y1 is equal to m times x minus x1. So let me go ahead and toss that in to our equation, or as an equation. Y minus y1 is equal to m times x minus x1. Okay? And remember, we can go ahead and label these. Last time I showed you, hey, it's easy just to kind of forget where you are. It's good to label everything ahead of time, and that way you can just go back and substitute those values in. So what we have now is we'll just substitute these in. Y minus y1, which is a minus 3, okay, is equal to m, which is 3, x minus x1, which is 2. So I'm subtracting my x1 value, which is a positive 2. And now what we get, let's just simplify this. Y plus 3 is equal to 3 times x minus 2. Let's multiply this all out and get it into the form that we need it to be in. Because usually what we want to do is we want to transition it from this form into, we want it to be the y is equal to mx plus b. Okay, that's generally what we want to do, is to represent it like that. So now let's just subtract 3 from both sides. Actually, before we do that, I'm not going to do that yet. We'll do that in just a minute. I'm going to multiply this all out. So we've got y plus 3 is equal to 3 times x, so 3x. 3 times a minus 2 is a minus 6. And now I'll subtract 3 from both sides. Okay, I'm running out of space, so I'll come up here. What we have is y equal to 3x. Minus 6 minus 3 is going to be a minus 9. Okay? So this right here is our final answer. Y is equal to 3x minus 9. Okay? So what you'll notice, actually, if I were to ask you, hey, what's the y-intercept of this question? This isn't the question. It's not in the question, but I do want to show you how to do that real quick. You get this. This right here is our slope, which was given to us right at the very beginning. The y-intercept actually is just going to be at the point 0, minus 9. So the y-intercept is 0, minus 9. That's the point that we have. So that's an x value and a y value associated with it. Now, the cool thing is that this method, or this particular formula, we can use any point anywhere on the graph of the line to give us ultimately this form over here, and then that you can find the y-intercepts from. So you don't actually need the y-intercept to put or to create the equation of a line. You can use any point and then change it into the proper form. So the way I like thinking about it is that this right here is used for like general cases, like any point you want. You can use the y-intercept if you want, and you're going to get the right equation. This is very specific. This form right here is a very specific form, and it only applies in really one case, and that's when it crosses the y-axis. So this is such a handy equation just to memorize. I encourage you guys to go ahead and do that. All right, so let's go ahead and do another problem. Let's do question 20. So question 20, they give us the point 5 minus 1, and the slope is going to be m equal to 1/5. Okay, so we actually have a fraction here. All right, so let's write our equation out. Y minus y1 is equal to m times x minus x1. All right, let's label these points x1, y1, or the values of those points, I should say. So y minus y1 minus 1. So remember, this is a minus 1. We're subtracting what the value of that y1 is, right? So some of you are probably going to say, oh, it's a minus 1, so y minus 1. Well, that's actually not the case. It's y minus a minus 1. So here we have m, which is 1/5, times x minus x1, which is 5. So now let's go ahead and distribute this. We'll multiply this all out. I'll just change this into the proper form. We've got 1/5 times x. 1/5 times a minus 5 is going to be a minus 1. You can go ahead and multiply that out. I promise you that's the case. And now we can subtract 1 from both sides. Y is equal to 1/5 x minus 2. A minus 1 minus 1 is going to be a minus 2. So that is our final answer. That is all we had to do. We had to put it. Remember, this right here, we're putting it into the form y is equal to mx plus b. Okay, so that's what our final answer looks like. It has to look like that. Okay. All right, let's do another one. We're gonna do a few more. This section actually is just a lot of repetition, so I'm only gonna do just a few examples, and you'll actually see this is probably not going to be a super long video at the end of our time. So 48. Now this is going to be a trickier thing. This is going to be involving questions from previous sections that we've gone over. So for example, if you have to find the slope, right? You're given 2 points, you got to find the slope, but you also have to put it into the proper form. So how do you do it? So in this case, question 48 asks us to find the equation. Find the equation of the line. Let's see. Through the given points. Passing. I think it's passing through the given points. Passing through the points, and I'll call them. So this is what we'll do. It's 1, 5. And the other point is going to be 3, 9. Okay? So right off the get-go, let's just label these, okay? Here's my x1, here's my y1, here's my x2, here's my y2, okay? Every time we get a point like that, we have to use our formulas for x1s, our y1s, x2s, y2s. Let's just label them right off the bat, okay? So what do we need? We need the slope. We don't have the slope. We need a point. Well, we have 2 of those, so we can actually find the slope just from those points right there. So m is going to equal, and I don't know if I remember if I did this last time or not. The little triangle means the change in y over the change in x, right? The little triangle right there means the change in. So the change in y over the change in x. This means y2 minus y1 all over x2 minus x1. So this is the slope that we went through the last time we looked at this content. Okay, the last section was going over the slope. So let's go ahead and substitute these in. We have to find the slope, and then we can go in and start substituting these values into our equation to help find what that equation will be for the line, for the straight line. So y2 minus y1. So we've got 9 minus 5 all over 3 minus 1, and that is equal to 4 all over 2. So the slope is actually equal to 2. Okay, so m equals 2, our slope. So now here's the cool thing: we've got our slope, and we've got both. We've got 2 points to the line. Now the cool thing is it doesn't really matter which of these points you use. You can use the first one, you can use the second one. It doesn't matter. It's all going to work out to being exactly the same in the end. And so I'm actually going to demonstrate that for you right now. So let's just go ahead and use the first point to see what we get. Y minus y1 equals m times x minus x1. Y minus, this is going to be 5, is equal to 2 times x minus 1. So this is 2x minus 2, y minus 5. Let's go ahead and multiply or move things over, so we just add 5 to both sides. Okay, and we get y, I don't know if you guys can see that, is equal to 2x minus 2 plus 5 is going to be a plus 3. Okay, so that's just using this point right here. Now what I'm going to do is I'm going to do the exact same thing using this point. Okay, and I'm going to show you that this is actually going to be exactly the same. So again, you can use either one. It doesn't make a difference. I'm just showing you what they would work out to be if I used either or. So I've got y minus y2, I'll call it, m times x minus x2. Okay. So I've got y minus 9 is equal to 2 times x minus 3. Okay. This is my point. And now what we're going to do is multiply this all out like we did before. 2x minus 3, or 2x minus 6, I'm sorry, y minus 9 here, add 9 to both sides, and we get y is equal to 2x plus 3. Now look at that. This guy and this guy are identical. So again, I'm just demonstrating what happened if you used the other point as opposed to the very first one that we did. So you get the same answer no matter what. So that's cool. It gives you a little bit of flexibility to choose which one you want. And yeah, there it is. That's the equation of the line going through that point. All right, let's go ahead and jump to our next question. Just a heads up, I'm probably going to have to change office hours. Unfortunately, a lot of our our meetings, our staff meetings that we have occur at 11 o'clock in the morning, and so I might have to change it from 12 to 2 on Thursdays, and so just keep that in mind. I'll probably send out an announcement in the class for what that looks like. All right, so here's a quick side note, and I'm going to star this side note, okay? There's my starred side note. So if you need to be on the lookout, so write this down. Be on the lookout for points that have the same, or points with the same x or y values. Okay, what do I mean by that? So let's just, for example, let me just shoot out an example to you. Okay, if I have the point 3, 4, and I'm asking you to find the equation of the line with these 2 points, 3, 4 and 3, 7. Okay, one of the things you'll notice right off of the bat is that the 3's are the same. Okay, so let me actually show you what this looks like on a graph. Here's our x, here's our y. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. 2, 3, 4, 5, 6, 7. Okay. So now what we have here is the point 3, 4. So we go over 3, up 4, and here is our point. This is 3, 4. Okay. And then above it is going to be 3, 7. So it's going to be right up here. Check out what happens. If I were to draw this straight, that's a straight line. Just imagine that's a straight line. It's a straight vertical line, right? The values 3 and 3 for the x, if they're the same, that means that we're going to have a vertical line here. And in fact, the vertical line is going to occur at x is equal to 3. That is actually the equation of the line. So if you see x values that are the same, you just say x equals 3, or x equals whatever the same number is between the two of them. It makes life a lot easier when you see something like that. Now, here's the thing. If I have the same y values, imagine I've got, let's say I've got the points. Let me try to find something that works with my scale that I created. How about 3, 4, and minus 2, 4. Okay, so notice the y values now in this case are exactly the same. So over 3, up 4, I've already got my point there. Minus 2, up 4 is going to be right here, right? And if I draw a straight line connecting those 2 points, what happens? It's a vertical line, or sorry, a horizontal line. Wow. So this right here is a horizontal line. At y is equal to 4. So the y value of the same points when you're connecting 2 points together, if they are the same, then it's just y is equal to whatever that number is. So previously it was x equals 3. This one's going to be y is equal to 4 for a horizontal line. Okay. There's actually a couple of questions on the homework you'll see where those crop up, so I do want you to be prepared in case that happens. Remember, look for the same x values and y values, and that should tell you what to do in that instance. Okay? All right, well, let's actually do an example. Here's what it is. So if I've got... well, let's just do a more complicated example here. Okay, let's do 5, 9, and minus 5, 3. Okay. Now notice these do not have the same x values or y values. Okay, this is not going to be a horizontal line or a vertical line. Minus 5 and 5 are not the same. 9 and 3 obviously are not the same, but yeah, these are not going to be horizontal or vertical lines. So first what we need to do is we need our slope between the 2 points. So we start with our m. Remember, it's our change in y over our change in x. So this is y2 minus y1 all over x2 minus x1. And let's go ahead and label these. x1, y1, x2, y2. And now we can just make our substitutions. So we've got 3 minus 5 all over. Oh, I'm sorry. Wow. Hello. Let's redo that. 3 minus 9 all over minus 5 minus 5. So what do we get as a solution? We get a minus 6 all over a minus 10, which is the same thing as a 6 over 10, which is the same thing as a 3 over 5. You can reduce it down even further. I'll leave that to you as an exercise to work that out, but I promise you it works out to being that. So that's our slope, and again, we can use any point we want. So we'll do y minus y1 is equal to m times x minus x1. So y minus y1, which is 9, is equal to 3/5 times x minus 5. There we go. You can't interchange these points. They got to be those exact points. So I need x1 with y1, x2 with y2. I can't do an x1 with a y2. It just will not work. So let's go ahead and multiply this all out. We get 3/5 times x minus 5 times the 3/5. The 5s are actually going to cancel in the denominator. So what I'm going to be left with is actually a minus 3. Again, you can work it out if you don't believe me. And if you're confused on that, I would encourage you to actually go work it out. Don't just take my word for it. This will actually be really helpful for you if you go and do the work to make sure that what I said is actually true. Okay, so now what we've got is y minus 9 on this side. So we're going to add 9 to both sides. And what we're left with is y equals 3/5 times x minus 3 plus 9 is equal to a plus 6. Okay, and that is our final answer. All right, well, that's really all I've got. It's amazing. We went through this stuff pretty quick. So feel free to go through and take a look. If you've got questions on the homework, let me know. Other than that, I will be probably posting another lesson here in the next couple days. But this should be pretty sufficient, I think, to get you through at least Thursday night's homework. So yep, here we have it, and I'll be seeing you guys at some point. Well, if you come visit me during office hours, then we can chat and have a good time, and you can ask any question you want. All right, have a good one.